The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
Electric vehicles have dominated the conversation until now, but energy storage is in its infancy. Its growth in terms of absolute numbers, it's on the same growth curve as EVs, just shifted 5 years. And if you do the math and assume the fully renewable world we want, there actually will be more. And in that scenario, there's very likely to be a lot more batteries used for energy storage than electric vehicles.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by the Clean Power Consulting Group. Please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple and Spotify so that others can find this content. Today on the Clean Power Hour, a safer non-lithium battery. My guest today is Ryan Brown. He is the CEO and founder of Salient Energy. Welcome to the show, Ryan.
It's my pleasure to be here.
I've had a slew of battery companies on the show now, and I'm thrilled to do that. It's, storage is the perfect complement to solar and wind. And so we need terawatts and terawatts, or terawatt hours and terawatt hours of storage. And it's a both and, right? There's lithium battery en masse now electrifying transportation and electrifying the grid. And now there's a handful of competing technologies, and you have one of them. Tell us a little bit about yourself. How did you get interested in storage, and what is Salient up to?
Yeah, great. So I got interested in storage because I started school with the sole objective of becoming very rich. So I went into a finance program. I got an internship at an investment bank, and it took all of about 3 weeks to realize I had made a terrible mistake. And so at that point, I had my quarter life crisis where I realized I would want to work on climate change. I restarted school, went into engineering, and tried to think of where I thought the next biggest technological frontier was in the fight against climate change. Batteries popped up. This was 2013. So I said, I'm going to get into batteries. Batteries seem like the big thing the next big thing we have to figure out for the energy transition. And then 5 years of working in research, working at other battery startups, I had the great fortune of having a lab mate invent our new Zinc-ion technology that led to Salient Energy.
Cool. So what differentiates Salient from all the others, and how are you planning to go to market?
So zinc batteries have been around for centuries. The first battery ever made was a zinc battery. But the problem with zinc batteries in the past has typically been around rechargeability. The best zinc batteries in terms of how much energy they get and their performance have always used a really high pH alkaline electrolyte. But the problem with those systems is that they don't recharge easily. So these are your disposable Duracells. There's a reason you're not supposed to recharge them. They can short circuit and have big problems. And while there's been a lot of work on making alkaline batteries more rechargeable, if you're creating a battery that needs to last 10 to 20 years and be paired with solar, you really need to get a new type of chemistry where rechargeability is easy. And what makes the Zinc-ion battery different is there was a bunch of high pH zinc batteries. There's a bunch of low pH zinc batteries. But we're the first one to have this like middle of the ground sweet spot cell that is enabled by our new type of cathode. So our new type of cathode works in neutral pH, and that neutral pH makes it easy to recharge a battery thousands of times. And that's why we're really excited about Zinc-ion's potential to replace lithium ion in stationary energy storage.
Okay, so the market is stationary storage. I see that you've struck a deal with a home builder in the Sun Belt, Texas, across the Southwest. What's the status of that project? And tell us a little bit about why you've chosen the residential storage market as a toe in the water.
Great question. So the residential market is a really great first market for any battery startup because you can get your products to market quicker. They're smaller, so you don't need gigafactories before you can fulfill your first project. And what they care most about is safety. So we have a water-based safe battery. The residential market values that above everything else. And then by finding good customers in the home building segment, we know that we can quickly get products to market, scale, learn quickly, and then use that knowledge to go into utility scale projects. The reason we particularly like working with sustainability focused home builders is because they have, one, they love clean tech. There's a reason they are, building net zero communities. They're amazing, enthusiastic early adopters. And they're also planning on long time scales. So in the past few years, there's been major disruptions to the lithium ion supply chain. Energy storage systems are experiencing 6 to 12 month delays. If you're planning a development 3 years out and it's a big development, if your battery holds up your entire project by a year, that's a major issue. So these people are planning today for the batteries of the future. And what they really want is safety and a secure supply chain. So we're working with those home builders as our first customers, developing products with them, specifying pilots with them, with the goal of becoming the kind of main supplier for that segment as we build our own large factories a couple of years out.
The Clean Power Hour is brought to you by DynaWatts. If you're a solar PV asset manager or performance engineer, you need better data and better business intelligence. With DynaWatts digital twin benchmarking technology, you get more accurate, efficient, and faster performance measurement results. The 4th generation Dino recently completed a technical review by DNV. You can download the report at dynawatts.com. That's DENOWATTS.com. Now back to the show. So I resonate. I want a battery in my garage that is as safe as the refrigerator or freezer, right? You don't want to have to worry about thermal runaway. And lithium ion is off to a mixed start on that front for sure. I think that the news media likes to blow that up a little more than, reality, so to speak, right? Every EV car fire is in the news, but let's face it, ICE engine cars catch on fire all the time. And they're just not in the news because it's not news anymore. So I think it's a both and. I think Elon Musk is a very smart guy. And if he didn't think lithium ion was going to work, he would do something else. And if he thought something else was going to work, he would do that too. So that's something I always ask, my guess is, well, why isn't Elon doing zinc batteries? If it's such an ingenious invention, and your point is well taken. 100-year-old technology, right? Just next generation of rechargeable zinc batteries. That sounds good. Sounds like there's less supply chain issues, less safety concerns. Check those boxes. Why isn't Elon doing it?
Great question. So if you think about the company that Tesla is, they're an EV company. And if you think about all the battery suppliers in the world right now, their main focus is the electric vehicle market, where lithium batteries are king. And they're always going to be king because their energy per weight which is absolutely critical for anything on wheels, is unbeatable. And so for these companies, their main focus is securing quality battery supply that they can use for their EVs. And then if they're really good at making battery packs for cars, they say, why not also make lithium ion based battery packs for residential energy storage? And that's the obvious solution until now, when there's just so much rapidly scaling batteries. And until recently, the price was always falling. So everyone was excited that, okay, continued EV sector growth will lead to ever cheaper, ever more available, ever better batteries. Of course, we'll use them for both markets. Mm-hmm. What we're seeing now is that because the materials used to make lithium-ion batteries are in short supply, we're seeing companies like Tesla and others diverting batteries that would otherwise go to their energy storage segment to get them in their cars. And that trend's growing. So batteries that used to seem too heavy, like LFP, people were like, oh, those will never be in cars. Now that's going to become the new standard. And so the EV market's eating up all the lithium ion batteries it can appropriately, because they absolutely need that low energy per weight. Mm-hmm. There is one major battery company that is, has seen the writing on the wall, CATL. They're developing sodium ion, where the first market's going to be energy storage, because they know that for us to have the energy transition we want, we can't be bottlenecked by the lithium supply chain.
Yeah, I did notice that CATL is expanding into other technologies, so that's interesting. And I would only disagree with one thing you said, and that is that I think Tesla is a robotics company disguised as an automobile company. And we just don't see that yet, right? The robot that they're making is in the shadows. But anyway, point well taken. And I hope you're right. I hope that zinc has the legs that you and others are saying it has, because I'm very concerned about the lithium supply chain, more so than the safety features. I think that we can figure out the safety features eventually and prevent thermal runaway in lithium batteries. But supply chain is a real problem. Lithium is super abundant. Is zinc as super abundant as lithium, relatively speaking?
So, yeah, in America, we make pennies out of zinc. So it is orders of magnitude more abundant. Its production, that there's both domestic mining and processing into battery grade metals. And crucially, recycling it is like dead easy. This is not something we have to figure out anew. So there's way more zinc. And when I say more, I don't mean reserves. I mean actual annual production and processing capability. Mm-hmm. So it's a higher capacity supply chain. It's a domestic supply chain, and it's more recyclable. So zinc is a very great candidate for batteries that can be heavy, i.e. stationary energy storage, but want to use safe, local, abundant, and inexpensive materials.
Yeah. So let's talk about the residential storage market. I like to say that today only a fraction of a % of people have a battery in their garage, but in 10 years, everyone's going to have a battery in their garage. It's going to become an appliance, a standard appliance in all homes and commercial buildings, frankly. It's just a great device for reducing your energy load and saving money. And you can, of course, store extra solar. If you have extra solar, you can store extra grid energy for when the grid goes down. You can have that resiliency. You can, you could do a lot of things. The value stack of storage is impressive. And it's complicated because it's different in every jurisdiction, meaning every locality, every utility, every state, every region has a different value stack or a slightly different value stack. And so it's non-trivial. Here in Illinois, we have fantastic incentives. We have a $250 per kWh incentive for batteries. And that means the battery is cash positive in year 1 or 2, and the rest is gravy, right? So what is your take on the residential storage market? that story in PV Magazine, which we will link to in the show notes, says that Horton World Solutions plans to build 200,000 homes, and they are quoted as being a sustainable home builder. So I don't know like what part of their portfolio is quote unquote sustainable homes, but anyway, they're certainly planning to put batteries in a large number of homes, it sounds like. So how do you meet that demand, and what do you think consumers are looking for just in terms of some of the basic specs? Is it a 10 kilowatt hour battery or a 15 or a 20? There's various flavors of residential batteries in that 10 to 20K range, and then some of them are modular and scalable in chunks of 10 kWh, which I think is cool because truly you need 30 plus kWh to have a home that could operate off grid, and a big solar array, right? So, but what is your take on the resi storage market?
Great question. So individual consumers have driven residential demand up until now, and it's primarily been like a luxury purchase or a peace of mind purchase to have protection against backups. The key thing to realize about residential energy storage is that it can do, as you said, so much more. And so if you think about what sustainably built homes, and by that I mean low emissions homes, will have to look like really quickly, that's replacing everything that's powered by natural gas to be powered by electricity, charging an EV in the garage. And so the electricity consumption of these new homes is going to look very different. It's going to have way higher peaks. And that creates a big problem for a rapid transition away from fossil fuel use in the home, where now we're going to have a drastically changed electricity load profile on legacy infrastructure. And so the new value, instead of being a luxury or peace of mind purchase by individual homeowners, is that there's increasing recognition that having a battery in the home is actually a key way to get our existing wires and our existing grid infrastructure to be able to take on more electricity demand from clean appliances, clean heating, and then also an energy supply from distributed solar. So the key value for residential, in my mind, coming forward, is by creating flexibility that will allow existing grid infrastructure to go further in the energy transition. And that's what home builders like Horton World Solutions and others have found, is that when they're designing for all electric, having the batteries in the home is the difference between a regular utility substation being hooked up to their community versus something completely different that's way more hard to integrate. So that's new build. And then what we're also seeing in California and in Texas is that because there's so much money to be made from providing resiliency, there's new business models emerging of companies putting batteries in people's homes, saying, don't worry, I'll be there in a blackout, otherwise leave the operation to us, and then owning a fleet of batteries that they operate as effectively a power plant to add resiliency in the grid. And that becomes a very financially attractive business model. And so in short, the residential market is really in its infancy and really starting to prove the case of how it can make energy infrastructure ready for the clean energy transition quickly.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Yeah. It's only a question of how fast we can make the energy transition. We're going to make it. We have all the technology we need, We just need the ability to deploy, and afford. And that's why industrial policy like the IRA legislation that we got in 2022 is so important. It does soften the blow of electrifying your home. And, truly we can do away with gas furnaces. And some communities have started to outlaw gas appliances. So we see the writing on the wall that this is happening and is the future. It's just a question of how fast, and can we do it fast enough to prevent the worst, so to speak, of runaway climate change, and depends on who you talk to what that means, the worst. If you're living in the less developed world on the coast, you're already experiencing some of that worst, and it is causing mass migration and starvation already. Not so much for you and I yet, but so I guess I'm curious, when you look into your crystal ball, where is the residential storage market taking off now? And, of course, California is the most mature market for storage, California and Hawaii, and they have very special rules now in Hawaii, and, about non-injection where your solar can't feed back onto the grid. So batteries are, essential really for anyone with solar. And then now in California, we have NEM 3.0. The new net metering rules in California are not very consumer friendly and will continue to drive consumers to residential storage as a play to make solar plus storage more economical. I look forward to talking with Julia Piper and others about that particular phenomenon. But what do you see in your crystal ball? And then let's talk a little bit about scaling, because that seems to be a pretty big deal in this world, right? And you have taken a somewhat unique stance on this, I think. But what do you see? What states should people pay attention to in your mind? And how do you get into hundreds of thousands of homes from hundreds? I would imagine you're still at a very early stage. So let's talk about that.
Yeah. Quick disclaimer: I'm a chemist, so the complexity of government regulation is above my pay grade. I'll take a stab, but there's a lot of interesting stuff happen. You have very forward-thinking utilities like Rocky Mountain Power, who has taken the proactive step of creating their own virtual power plant program and encouraging behind-the-meter storage, and seeing a lot of uptick there. Texas is a really interesting market, not because of progressive policy, but just because of the huge windfalls that providing energy during times of grid stress have created. It's just creating great business models for large scale integrated distributed energy storage projects. And then, as you mentioned, California. The thing that I'll add on to what you said is that actually part of the new California building code mandates batteries in multifamily and commercial buildings. It requires new build residential to be ready for batteries. And so if all new buildings by decree have to have solar, if a lot of them need batteries and then the rest have to be battery ready, then I think California can very quickly become a state where energy storage is widely distributed. And so I'd say overall, look for utilities that have these programs. These are people that have seen the value of using batteries to delay infrastructure investment. Look for states like California that are very progressive in mandating adoption, and then look for states like Texas, the existing economics without government regulation create an incentive for energy storage to provide power during these stress events. For scaling, from our perspective, we always started with scale in mind, and that means we source abundant materials that are using domestic material supply chains. So that's specialty high grade commodity zinc. And then our cathode material is manganese dioxide, which is used in disposable batteries. We do some, special stuff to it to make it good for our batteries, but this is stuff that's produced at scale. So step one, source commercially available abundant materials. And then step two is we actually use the same fundamental production processes as lithium ion batteries. So we're not changing the model of how our battery factories work. We're using the same equipment, we're using the same know-how. So that's why we're confident in our ability to scale rapidly. We're using a scaled supply chain and we're using mature production. And so the barrier for us is just how quickly can we get the money to build a big factory and how quickly can we get the orders to fill it? I think it's still, it's not, this isn't a software business where you can go from 0 to 1 billion users in 2 months. But I'm excited that we can be a major supplier of this industry in the latter half of this decade.
And do you have to build your own factory, or can you contract manufacture these cells and modules?
We can contract manufacture. The issue is, just like everything in the battery industry right now, is demand's outstripping supply. So everyone's, part of the Inflation Reduction Act. We need to stand up a battery industry that can be separate from China basically overnight. There's a lot of companies building EV batteries. All those companies are using contractors to qualify designs. So the best way to own the quality and rate of scaling is to do it yourself. Of course, we were using contractors until then, but our goal is to own our own manufacturing, own our quality, own how quickly we can scale.
And, you mentioned the latter half of this decade. Paint us a picture for, what are you producing today? And then how is that changing over time? Are you still waiting for some breakthrough on the technology side, or is it strictly a matter of amassing the resources to build the gigafactory?
So today we build large pouch cells that are going to be fine for our first residential product. We're getting that residential product ready for certification and in-field pilots this year. And then our focus next year is getting, the ball rolling on sales so that we can have, let's call it, thousands of homes that we're supplying in 2025. And if you actually compare that that's like megawatt hours, tens to hundreds of megawatt hours of battery. So that's a pretty modest battery factory. But our focus there is get a product out to market, be able to do it quickly, and use that success in the residential market to then build the gigafactory. And, I would like to have infinite money to build an infinitely big gigafactory. But that's our roadmap. There's been very good funding for proven battery technologies with good commercial prospects. So our kind of key defining moment will be, how successful are we in 2025, and how enthusiastic is the market for funding the scale up of the battery industry then.
The Clean Power Hour is brought to you by Dynawatts. If you're a solar PV asset manager or performance engineer, you need better data and better business intelligence. With Dynawatts digital twin benchmarking technology, you get more accurate, efficient, and faster performance measurement results. The fourth generation Dino recently completed a technical review by DNV. You can download the report at dynawatts.com. That's DENOWATTS.com. Now back to the show. Cool. Well, I don't really have any other questions for you. What else should our listeners know about Salient and the residential storage market?
Good question. Yeah, I think the first thing to appreciate is electric vehicles have dominated the conversation until now. But energy storage is in its infancy. Its growth in terms of like absolute numbers, it's on the same growth curve as EVs, just shifted 5 years. And if you do the math and assume like the fully renewable world we want, there actually will be more. And in that scenario, there's like very likely to be a lot more batteries used for energy storage than electric vehicles. So even though energy storage has until now and appropriately been the less important market, that's going to change quickly. And once that changes, we are going to get away. We're going to see a deviation between EV batteries and energy storage batteries.
Mm-hmm.
And energy storage batteries are going to be safe, cheap, recyclable, won't worry about weight. Otherwise look a lot like lithium-ion batteries. And so when thinking about this market and all the different technologies and looking at those, think about which of those new technologies can slot in as the lithium-ion replacement, which of them have the long-term supply and cost and recyclability prospects needed to supply this, what will be a massive industry. And do your research, because there's lots going on. There's lots of exciting stuff. It's not going to be winner take all. The energy storage segment's not a monolith. Most of it is like most of it will be like the products we see today, which is 2 to 6 hours of energy storage in modular systems that size from residential to utility scale. But there's also going to be big segments of long duration storage and stuff that is serving other applications. So market in its infancy, lots of growing left to do, lots of nuance to emerge, and just generally an exciting time.
Totally agree. I did think of another question. I don't know if you can answer this, but I went to a SolarEdge training recently, and they have their own 10 kWh modular battery. It's about 24 inches wide, 36 inches tall, 10 or 12 inches deep, and for the residential market, it weighs 275 pounds. Now, this is an NMC battery. Nickel, manganese, cobalt, which is the fanciest type of a lithium battery made. Their partner is the company that made the batteries in that solar airplane that flew around the world on solar power.
Oh, cool.
Yeah. But do you know what a comparable Salient battery would weigh? I'm just curious to get a sense of the delta. You know, if NMC weighs 275 pounds, I imagine the zinc has to weigh more. Is it 300? Is it 320?
Yeah, I'd say so. Not knowing all the components that go in the energy storage system and what weight they add for that system, I'll just say rule of thumb, assume it's twice as heavy. Okay. Which is why these batteries won't move. All you have to do is make sure that your modules are the right weight for your installer to slot them in there and wire them up. And then, don't expect to be wheeling it out for a picnic.
Nice. Well, please check out all of our content at cleanpowerhour.com. Give us a rating and a review so others can find this content. And please subscribe to our YouTube channel. Just hit the YouTube icon at cleanpowerhour.com and get all of our videos. Every week we're producing 2 videos, one-on-one interviews like this and a news roundup with my co-host John Weaver, or an occasional guest co-host. So Ryan, how can our listeners reach you and Salient?
You can find me on LinkedIn, Ryan Brown. The website is salientenergy.ca, or find us on LinkedIn and Twitter. I love getting messages, especially if it's about nerdy battery topics. So yeah, feel free to reach out.
Excellent. Well, I'm Tim Montague. Thank you so much, Ryan Brown. Let's grow solar and storage.
Absolutely. Thank you so much.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 3-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes 3-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.